Let's take a look at today's lesson. We are going to be working with limits algebraically, not graphically like we did last time. So algebraically is a little bit different than using graphs. Here we will work, with algebra techniques, and that's what we're going to be looking at. So let's look at the properties that we have, which are quite nice and very useful for us as we work some, depending on the level of complexity, which ones we need to use. So let's look at these properties. And the great news for us is this certainly will be your first unit in calculus. All right, so, okay. There we go. All right. So on this first one, we have the scalar multiples. So we basically are multiplying by an a. And so like a 2. Let's say we have to multiply by 2. Then we can pull that 2 on the outside of the limit statement. We can pull that on the outside, and that's perfectly fine. On the second one, we can separate them. We can basically, if we're doing the limit of f of x plus g of x, we can pull them apart. We can do the limit of f of x first, then the limit of g of x, and then add those together. That's certainly okay. It's possible to do. On the third technique, if we're multiplying two functions together, we can do, again, we can rewrite it. We can do the limit of the first one times the limit of the second one. Do those limits separately. It's kind of a nice little thing that we can do. And the fourth one, again, we could do that with multiplication. We can also do that with division. We can do the limit of the numerator separate than the limit of the denominator. Of course, provided the denominator is not 0, the limit's not 0, that's another issue. So that we've got that option. And the last one we're going to talk about is this one, where if we have a function raised to a particular power, like squared or cubed or something, we can pull that power on the outside of the limit. We can take the actual limit and then apply the power. So we've got quite a bit of flexibility with these limit laws. Alright, so those are the limit laws. Now let's look at some techniques that we might want to keep in mind as we're working these limits algebraically. The very first thing that we're going to do is we're going to plug in the x value. So wherever we're going, if we're going to 0, we plug a 0 in. We're going to plug that in. And so we're going to plug that in first. If we get a number, we're done. We plug in it, we get a number, we're done. Okay? If it causes the function to be undefined, and let's talk about what it means by undefined. What I mean is if the function gives us a number like 0 over 0, which is called an indeterminate form. If it gives us 0 over 0, that means we need to keep going. We need to do more stuff. We need to do some algebraic stuff to rewrite it. If the limit is like 1 over 0, which could happen with like if we're doing algebraic limit with secant or cotangent or tangent, all those asymptotes that they have. If we plug in a number, we could certainly get like 1 over 0. That would identify there's an asymptote there. So if it's like 1 over 0, 2 over 0, something like that, that means there's a vertical asymptote there. But if it's 0 over 0, that means there's an answer. It's kind of buried in there. Oh, you can think of it like buried treasure. It's like buried in there. We're going to have to find it. And so these are the techniques that we use to find that number, that answer. We could use one of these limit properties right here. We could use those to change the way it looks, to reduce it. We could find a common denominator. We could do that technique if we have two fractions. If we have like one fraction and we're getting nowhere, we might multiply by the conjugate. We could try factoring. We know we love factoring, right? That comes in quite handy. GCF, or maybe special factoring like x squared minus 1, perfect difference of perfect squares. We could, maybe it's a trinomial and we could factor like FOIL. We got lots of options we could look at. So we could substitute a trig identity if that helps our case, it helps us out. We can rewrite it that way. Or we can do one of these two special trig limits. Okay, these are ones you have to memorize. You have to memorize these, and I'm going to explain them. So the first one, the limit as x goes to 0 of sine x over x equals 1. That's quite a flexible limit, and we need to recognize its flexibility because I'm going to be testing you over its flexibility. Do you know how this works? So if we have the limit as x goes to 0 of sine x over x, it's 1. We could also, the limit as x goes to 0 of x over sine x, that's also 1. That can be flipped upside down. So it could be the limit as x goes to 0 of x over sine x, that is also 1. So its reciprocal also works. What we're looking for here is the number that we plug in needs to cause this to be 0 over 0. This number does not have to be a 0, it just has to cause this expression to go to 0 over 0. If you notice, if I put a 0 in, I get 0 here, sine of 0 is 0. Great, we've got 0 over 0. What if I had the limit as x goes to, let's say, 1 of sine of x minus 1 over x minus 1? Okay, when I put a 1 in, do I get sine 0 over 0? I do, so that works also, and that answer is 1. This is a quite flexible limit, very flexible. There's a lot of things that I can do with it. The one thing that's required, though, the one thing that is required, not only do I have to have sine 0 over 0, but this argument has to match the denominator. There are no exceptions. Has to match. So another example, if I had the limit as x goes to 0 of sine of 2x over x, I can't, even though that is sine 0 over 0, that's not ready yet. I need it to be sine 2x over 2x. Okay? So in this particular case, and let me write up a little bit higher so we can see it, the limit as x goes to 0 of sine 2x over x. For me to be able to use the special limit, I need a 2x in the denominator. I have to have a 2 down there. And we know this is an expression, it's not an equation. I can't just multiply by 1/2 just because I want to. I need to multiply by 2 over 2. I can only multiply by the number 1. So I'm going to multiply, and I'll put it in a different color. I'm going to multiply by 2 over 2. I'm multiplying by 2 over 2. And so this portion is the special limit. Right? That portion is the special limit. So the limit, and I'm going to split it up as x goes to 0 of, and we're going to use this right here, to bring the 2 out here, of sine 2x over 2x. Okay, so I'm using this special limit right here, property. So that is going to give me 2 times 1, or 2. So I have 2 requirements to be able to use this special limit. Requirement number 1 is when I plug in whatever number I have, it needs to create sine 0 over 0. Requirement number 2 is that the argument has to match the denominator. Now I hope that we are very clear that there is not a whole lot we can do with an argument without a, trig property. I can't just decide to divide that 2 out of there. That's not a thing. That 2 right here, that is not a thing. Right? In order to change that 2, we'd have to do some kind of crazy stuff, right? Either, just double angle, we have to do something. So that's not what I'm talking. We can't mess with that. It's the denominator we need to mess with and make it match the argument. Okay. So that is this limit. Quite flexible, quite lovely. The limit below it, the limit as x goes to 0 of 1 minus cosine x over x, which is equal to 0, not that flexible. Are you really surprised? It's cosine. Right, it's cosine. Not that flexible. I can't turn it upside down. If I turn it upside down, basically this answer would be like 0 over 1, right, or 0 over 10 or whatever, right? If I flip it upside down, what is going to happen to this? It's going to be undefined. I can't flip it upside down. It doesn't work that way. It's not nearly as flexible as sine. It has to look just like that. In addition, this argument needs to match that. They need to match. I really got nothing. I guess the only thing I could do is I could do the limit as x goes to 0 of cosine x minus 1 over x, because that would just give me, if I factored a negative 1 out of here, I would get negative 1 minus cosine x over x. And this would just yield a negative 0, which we know is just 0. It's not just 0. So that's as crazy as this one gets. I could change the order. I could do, instead of 1 minus cosine, I could do cosine minus 1. Ooh, that would give me like a negative 0. And there is no such thing as a negative 0. So, I mean, that's it. That's it. It's as crazy as that one gets. All right, questions so far? Okay, so what we're going to do, we have 4 examples on the next page, so we're going to practice these things. We're going to go through, walk through, and practice these together. So if you would, please turn to the next page. All right, the first step when we do limits algebraically is plug the number in. We're going to plug the number in and see what happens. So we've got tangent of pi over 4 over 1 plus cosine of pi over 4 squared. Okay, so we know tangent of pi over 4 is 1. Oh, this is looking promising. Over 1 plus. We know cosine of pi over 4 is root 2 over 2. So it's root 2 over 2 squared, right? Because we have to square it because it's cosine squared. So that would yield 1 over 1 plus 2/4, which is 1/2, right? So we have 1 over 3/2. That's our big fraction bar right there. Or our final answer is 2/3. So that one is like our dream problem where we get to plug the number in and it just works. Okay, it's rare, but it's certainly our dream, right? That's step 1, plug the number in. Okay, questions? Let's go to the next one. Let's plug the number in. So I plug a 2 in here. I get sine 2 minus 2, that's sine 0. 2, that'd be 4 plus 2. I get sine 0 over 0. Looks promising. Looks promising. I want to use the special limit, but I need the argument to match the denominator. It's not yet, but I bet we could factor. Right? Let's factor. So let's get rid of all that. Let's factor. So I have the limit as x goes to 2 of sine of x minus 2 over, let's see, this is what, x plus 3, x minus 2. Ah, here we go. This is our special limit hiding right there. Now what I'm going to do is I'm going to rewrite this so it's clearer that I basically have 2 limits that I'm working on here. So this is the limit as x goes to 2 of sine of x minus 2 over x minus 2 times the limit as x goes to 2 of 1 over x plus 3. I want to make sure we're all clear there. So I just split it. I used that property on the other slide of the multiplication, right? If we have 2 things being multiplied, we can split them and do the limit of them separately and then combine them together at the end. Is everybody okay with that? So let's make sure, because sometimes we get confused between multiplying and adding. So if I think about this times this, my question is, do I get this? That's what I need to ask myself. If I multiplied those 2 together, would I get back where I started? I would, right? So that's okay. I split it properly. All right, so now let's take the limit. Notice that when I take the limit, what it means by taking the limit is plugging the number in. When I plug the number in, I don't carry this limit statement with me any longer. But until I plug the number in, I have to keep it with me. It's telling me what to do. We cannot just drop it, or you lose points. I mean, you can't. You can't just drop it. All right, so let's take care of this limit. The limit as x goes to 2 of sine x minus 2 over x minus 2, according to our special limit, that's going to tend to what? 1. It's going to be 1 times. So now I'm going to plug a 2 into this one. 1 over 2 plus 3, 1 over 2 plus 3, so that's 1/5. So my answer to this limit is 1/5. Okay, questions on that one? So that was an interesting use of that special limit. We need to be looking for the special limit. And the two things, what two things have to be true to use the special limit? What two things have to be true? The argument and the denominator have to match. They got to match. And what's the other thing that has to be true? Right, sine 0 over 0. It needs to give us sine 0 over 0. Okay, those are the two things that have to be true to use that special limit. Okay, we got that? Okay, let's move on. This next one, if I put a 0 in, I have some crazy stuff going on. Let's plug in. So sine of 0 is 0, cosine of 0 is 1. This would give me 1 minus 1 is 0 over 0. If I put 0 in, that's what it gives me, 0 over 0, which means, please understand, 0 over 0 is not 0. 0 over 0 is something called an indeterminate form, and we don't know what it is. It could be 0 or it could be 25. We don't know. We've got to investigate. We've got to keep working. So when you are doing limits and you get 0 over 0 when you're plugging in, that's our first step, is to plug in, then you need to think, yay, I get to do more stuff. Yay, I get to keep going. I need to keep going. Okay? So we need to keep going. So let's think of how we could rewrite that. I think I want to rewrite it as 3 different fractions, or actually 2 different fractions. I want to write it as 2 different fractions. I want you to look at this little guy right here. He's kind of hiding. See this little guy hiding right there? That's the second special limit, kind of hiding in there, right? You see it? You see the numerator of it. You don't see the denominator, but that's the numerator, right? Cosine minus 1 or 1 minus cosine, right? We could use either one. Okay, so I'm going to rewrite it. All right, here we go. So we've got the limit as x goes to 0 of 3 sine x over 4x plus the limit as x goes to 0 of cosine x minus 1 over 4x. Now pause here for a second. Now this is where students get confused between addition and subtraction. Excuse me, between addition and multiplication. See, with the multiplication, these two denominators had to be separate because I'm multiplying. But when I'm adding, what's the whole rule way back to elementary school? To add fractions, you have to have a common denominator, right? So to add these two, so we're checking, if I add this plus this, would I get back to this? That's what I want to know. And I would, so I've done that correctly. We need to check. Please don't do any algebra mistakes here. So, okay, so I've got, actually, crazily enough, I've got kind of both special limits kind of hiding there, right? I've got the 3 sine x over 4x, which we're not quite good with yet. I've got the cosine x minus 1 over 4x. I'm going to use that very first limit law to rewrite this one more time instead of trying to do crazy stuff. I'm going to rewrite it one more time. So look and see what I'm going to do. This number right here is a constant. I'm going to pull it outside the limit. So I've got 3/4 limit x goes to 0 of sine x over x plus 1/4 limit x goes to 0 of cosine x minus 1 over x. Okay, so we're ready to evaluate. I've got 3/4 times 1 plus 1/4 times 0. I have both special limits there, which is kind of fun. So that gives me an answer of 3/4. Okay, how are we there? We okay? All right, last one. This one is kind of interesting. Actually, it's the definition of the derivative, but we don't have to know that. I'm just going to give you limit problems. Okay, so notice how this is the limit as h goes to 0. Notice how I have more variables than just h. I've got an x and an h. That's going to be important to us in a moment. Okay, it's going to be important in a moment. So what we need to do is, I can't really mess with it like this. If I put a 0 in, I get 0 over 0. So that's not going to work. Okay, so here we go. So let's use we need to break this apart. We're going to use the sign addition property to break that apart. So I got the limit as h goes to 0 of. So the sign addition property, remember sign is really nice. So it's going to be sine x cosine h plus sine h cosine x minus sine x over h. Okay. Everybody okay? So this actually takes practice. When we're looking at this, we might be overwhelmed, like what in the world am I going to do? What we would do is we're going to group together this sine x with this sine x. We're going to factor. Okay, we're going to factor. We're going to group these two together and we're going to factor the sine x out. So we've got the limit as h goes to 0. I've got sine x times cosine h minus 1 plus sine h cosine x. I'll pause there for just a second. Sometimes students need to rewrite it so that sine x cosine h minus sine x are right next together. Are we okay with that? You're like, sure, yes, we're great. We're okay? All right. Look at there, I got cosine h minus 1 over h kind of embedded in there. See that little crazy guy right there? Special limit? Okay, so I'm going to split this into two limits. So I've got the limit as h goes to 0 of sine x times cosine h minus 1 over h plus the limit as h goes to 0 of sine h cosine x over h. This is an adding one, right? I've got to have the denominator duplicated. It's not a multiplying one. So if I add those two back together, I get to where I started. Now, here's the kind of fun thing. This is the limit as h goes to 0. Okay, we need to have our phones away, please. This is the limit as h goes to 0. Okay, so just let me say, x does not really care where h is going. I know that's rude. That's very rude. But x doesn't really care at all. Doesn't affect him at all. Could care less. Okay? The limit as h approaches 0 has no effect on sine x, and it has no effect on cosine x. Why? Because it's don't have a variable h. You know, maybe they're friends, maybe they're hanging out or whatever, but sorry, sorry, if you're going to 0, I don't care. I'm not going. Okay? So let's look and see what happens for us then. So basically what I have is I have this special limit right here, right, that's attached to the h, and I have this special limit right here that's attached to the h. The sine x and the cosine x are untouched. So let's take our special limits and bring down everything else. Okay, so the limit as h goes to 0 of sine x is sine x. Sine's like, okay, great. Nice to know you. I'm not going. Okay. The limit as h goes to 0 of cosine h minus 1 over h. What's that? 0. That's our special limit. Plus, the limit as h goes to 0 of sine h over h. That's the special limit. It's 1. And the limit as h goes to 0 of cosine x is cosine x. Cosine x, you know, is not involved with the limit going as h goes to 0. So this goes away, and I'm left with cosine x. So this is a case where the answer to a limit is actually another function. What we just did is we used the definition of the derivative to find the derivative of sine. Just a little, fun fact. The derivative of sine is cosine. We have two variables, and we really wouldn't graph this. We would do this. This is an analytical way to find derivatives, which you will learn in calculus, and you're going to practice this year. Okay, how are we? We okay? All right, great. Let me get to your daily work.